Hello everyone, welcome back to my additional mathematics channel. For today's lesson, I would like to share with you about the permutation formative exercise in the textbook. Let's get started with the class. Have fun! So this is a formula for the permutation, which is NPR. N is actually number of the object, and R is how many objects that you taken to arrange. So we arrange R object from N object given. So it's NPR. Alright, so have fun. Formative exercise 4.1. A set of questions contains 5 true or false questions and 5 multiple choice questions, each with 4 choices. What is the number of ways to answer this set of questions? So let's solve this question. Since we have 2 ways to answer for the 5 questions, the answer for each question is true. So we draw 5 spaces, and each answer we actually have 2 choices, either true or false. So for all the 5 questions, each question we have 2 ways to answer, either true or false. And then we have 5 multiple choice answers. Since we have 5 multiple choice answer, that means the multiple choice we have answer like A, B, C, D, right? So we have 4 ways to answer for each 5 questions. So that means the number of ways to answer all the question is 2 to the power of 5 times 4 to the power of 5, or you can write as 2 times 2 times 2 times 2 times 2, 2 times itself 5 times, or 4 times itself 5 times. So the answer, if you press a calculator, will be 32,768 ways for you to answer 5 questions with true and false, and 5 questions with a multiple choice of A, B, C, D. Let's proceed to question number 2. Find the number of ways to create a 3-digit password for a lock if repetition of the digit is allowed, and then for repetition of digit is not allowed. So let's discuss A. Repetition of digit is allowed, meaning that we can use all the digit from 0 to 9. So we have 10 digits. So that means we can use back the digit that we use. So we have 10 times 10 times 10 choice. So the number of ways is actually 1000, right? And then for repetition of digit which is not allowed, since we cannot use back the digit that being used, so that means the choice will reduce 1 each time, right? So it becomes 10 times 9 times 8. So the numbers of ways will be 10 times 9 times 8, which is if you use a calculator, you can write 10p3. Alright, you can use the permutation, the NCR formula. So the answer is 720 ways. So there's a difference between repetition is allowed and not allowed. Now let's proceed to question number 3. For this question, how many numbers are there between 5,000 and 6,000 that can be formed from the digit 2, 4, 5, 7 and 8 without repetition of digit, and how many of these are even numbers? There are 2 questions here. So basically we study the condition is the numbers that you form from the digits 2, 4, 5, 7, 8. It must be lies between 5,000 and 6,000. Therefore, we have to be very careful to choose the right digit, which is digit 5. We have only one 5. So we need to start with a 5 so that the number that we form will lies between 5,000 to 6,000. So that is the only one way to start, which is 5. And then the balance, we can use up all the digits except 5. So we have 5 minus 1, which is 4 digits left over. So hence we have 4 digits to be used for the 3 space. It's 4P3, right? So since we have 1 5, we can say 1P1, or just one way to start, and we have 4P3 way to arrange for the next 3 digits. So the answer is just 1P1 times 4P3, and you can press your calculator to get the answer, which is 24 ways to form the number from digit 2, 4, 5, 7, 8 with a condition the number lies between 5,000 to 6,000. Now, how many of these numbers are even number? That means we still stick to 5,000 and 6,000. That means we must start with a 5. So since the 5 being used up, and we must end with the even digit, which actually they are 2, 4 and 8, which are even. So we have 3 ways to end. We can end with 2, we can end with 4, we can end with the 8. We have 3 ways to end. So we can say 3P1. Alright? Okay, so since we already used up 2 digits, alright, so we have actually 2, 4, 5, 7, 8, 5 digits. 2 digits being used up because of the condition. So the balance should have 3, right? So the 3 digit, we need to choose 2 digits to fill up the middle one, so that we will get the number that fulfill the condition. So if you multiply 1P1 times 3P2 times 3P1, you get the answer, which is 18 ways. Proceed to the next question, number 4. A couple and their 8 children are going to watch a movie in cinema. They book a row of seats. Find the number of ways for the family can be seated if the couple sit side by side. So since side by side means that the couple must be together, right? So we have 2 couples and 8 children going to sit in a row. So let's start with the condition the couple must be together. So that means we are going to put them into a box, or we can say that a container, so that we can make them together. So then how many ways to arrange the parents or the couple is father first followed by mother, or mother first followed by father. So we have 2P2, right, for us to arrange the couple to be together. There are 2 ways. Alright, after we arrange them together, we actually consider father and mother now is together as one object. So the children, we have 8 children, So now all the 8 children is going to rearrange with the couple so that we can see how many ways the couple is always together when they arrange among the children for the seat. So the way to arrange them is actually we consider the couple as one entity, and then with the 8 objects which are children. So it means that we are going to arrange the couple first, which is 2p2. After that we are going to arrange all the 9, okay, 9, which is actually couple considered as one because they need to be sit side by side. So it's 9p9 because of 1 plus 8. Remember that the couple must be considered as one object after we arrange them sit side by side. So the answer should be 2p2 times 9p9. So if you press your calculator, you will get a very big number, which is 725760. So there are 725760 ways to arrange the couple sit side by side with the 9 objects for us to arrange. Alright, so remember that even though the children is 8, but we have to consider the couple is arranged with them. So it's 9p9. So let's proceed to B. Sit at both ends of the row. Okay, for this one, the condition is we must take care of the starting and the ending. So sit at both ends means that the first space can be sitting by the father or mother, right? Okay, and if the father and mother decide to sit, maybe the father sit first, so the mother will be at the end, right? So we can start with either father or mother. So there are 2p1 way, or we can say that we have 2 ways to start, but after we start we have 1 way to end, right? So for us to start we have 2 ways. So we can say that is 2p1, right? Why? Because either father or mother can be sitting at the first space. Alright, so after that we will actually arrange the children. So the children, we have 8, right? So it's still 8p8 or 8 factorial. So the number of ways to arrange so that the parents sit at both ends of the row is 2p2 times 8p8 times 1p1, or you can write as 2 factorial times 8 factorial times 1. So the answer is 80640 way, right? If we follow the condition, we will get this answer for B, 80640. Now let's proceed to C. The C, we are asking to find the number of ways the family can be seated if the couple are sitting separately. So when sitting separately, we have to use the complement case. So meaning that we can actually use the number of ways to arrange all the objects. Consider that the couple can sit anywhere they like. That means we are going to arrange 10%. Why we say 10%? Because a couple consists of the 2 persons. Father and mother can sit anywhere they like. They don't have to be together. So we have to consider that we ask the parents to sit anywhere they like, and the children also can sit anywhere they like. That means out of the 10 person, they have the choice to sit the 10 seats. So it's 10p10, right? We have 10p10 for them to sit. So there are so many ways. And since just now for the A, we already calculated those number of ways for the couple sit side by side. So if we take 10p10, that means the couple can sit anywhere, minus out the number of ways whereby the couple sitting side by side. So that means the balance should be the number of ways the couple sit separately, isn't it? Logic, right? So we will take the answer 10p10, then we will minus out the answer for A, which is actually 2p2 times 9p9. So the answer that you get will be a very big number, which is 290, 30, and 40. So we have so many ways, okay, for the parent if they sit separately. Right, let's proceed to question number 5. Find the number of ways to arrange each word baku and baka if no repetition is allowed. Are the number of ways the same? Explain. So for us to arrange a baku, B-A-K-U, which is actually we arrange 4 objects out of 4, we arrange 4. So we have 4p4 in fact, right? So the answer is 4 times 3 times 2 times 1. So we have 24 ways for arranging the BAKU. Alright? If we want to arrange a BAKA, we must consider that they are 2 identical A, right? So we need to divide by the number of identical objects, which is 2 factorial. So the answer will be 4 factorial divided by 2 factorial. And of course the answer won't be the same. The number of ways of course will be less than the BAKU because due to the repetition of the A, right? So the number of ways won't be the same due to the repetition of the letter A for baka. That is why we have to divide the number of ways with the identical object that is repeating, right? Okay, so let's proceed to the next question. For question number 6, determine the number of roads for an object to move from point A to point B if the object can only move up or to the right. So since we have 2 ways of moving, either up or move to the right, so from A starting point moving to the B, so we will study how the object moves. So the object can move upward 3 steps with the same direction and then followed by 5 steps to the right. Okay, so you notice that when an object moves from A upward 3 times, the direction is the same, right? Upward, and then for the particle move to the right, is the 5 steps are the same, right? So that means the number of ways for the particle move, let's say we choose another way, this is 2 steps to the right, upward 2 steps, right? And then moving to the right, another 3 steps to the right and 1 step upward. So in short, no matter which road the particle or the object will move the direction 3 steps upward and 5 steps to the right in order to reach the point B. So we can say that the number of ways for the object to move is actually there are 8 ways, right? But since the 3 upward are considered identical, same way, and then the 5 are heading to the right, the 5 steps are identical, so we need to divide by 3 factorial and 5 factorial. Now, why we need to divide by 3 factorial and 5 factorial? Because the 3 step is moving upward and they are identical, and the 5 factorial is actually 5 steps to the right and they are identical, they are having the same direction and magnitude, right? So we need to divide by 3 factorial and then divide by 5 factorial, and if we simplify using calculator, we will get the answer which is equivalent to 56, right? Now let's proceed to the next question. Hi guys, finally we have reached question number 7. A group of 7 children are competing for 6 chairs that are arranged in a circle during a musical chairs game. So the children have to move in an anti-clockwise direction around the chairs. Determine the number of arrangement for the game. So because this is a circle, so we need to be very careful. The number of ways to arrange a circle is totally different with the number of ways to arrange the seat in a straight line. Okay, so now we have 7 children competing for 6 chairs. That means out of 7 they need to choose 6 places, so it's 7p6. Now we need to divide by 6 because the number of ways to arrange in a circle is always you have to divide by the number of positions in the circle. So 7p6 divided by 6, so we will press a calculator to get the answer, and the answer is equivalent to we can say that actually is 7 times 6 times 5 times 4 times 3 times 2 times 1. Now if you simplify the 6, you'll get the answer which is equivalent to, let's say you press a calculator, 7p6 over 6, isn't it the answer is 840, right? So this is actually the number of arrangement for this game, which is 840 ways. So that's all my sharing for the formative
谁在最需要的时候轻轻拍着我肩膀？谁在最快乐的时候愿意和我分享？日子那么长，我在你身旁，见证你成长，让我感到充满力量。谁能忘记过去一路走来陪你受的伤？谁能预料未来茫茫漫长，你在何方？笑容在脸上，和你一样大声唱，为自己鼓掌。我和你一样的坚强，一样的全力以赴追逐我的梦想，哪怕会受伤，哪怕有风浪 何方？笑容在脸上，和你一样大声唱，为自己鼓掌。我和你一样的坚强，一样的全力以赴追逐我的梦想，哪怕会受伤，哪怕有风浪，风雨之后才会有迷人芬芳。我和你一样的善良，一样为需要的人打造一个天堂。歌声是翅膀，唱出了希望，所有的付出只因爱的力量。我们都一样的坚强，一样的青春焕发金黄色的光芒，哪怕会受伤，哪怕有风浪，风雨之后才会有彩色阳光。我们都一样的善良，一样为需要的人打造一个天堂。歌声是翅膀，唱出了希望，所有的付出只因爱的力量。和你一样，我们都一样。谁在最需要的时候轻轻拍着我肩膀？谁在最快乐的时候愿意和我分享？日子那么长，我在你身旁，见证你成长，永远为你鼓